I did my presentation on the average pace of Chicago Marathon runners. Next slide. So a little bit about the Chicago Marathon. It's an annual marathon held in Chicago, Illinois. It's limited to 45,000 runners. For the 2011 average finish time, which is what I did my data on, it was 4 hours and 40 minutes, 39 seconds. And so the average pace of all the runners was 8.86 kilometers per hour. Next slide. Okay, so just mentally kind of guess what you expect the graph to look like over 42 kilometers. And then, that's good. That's the actual graph. So you can see that here it looks parabolic, and then here it's linear, and then it's another linear. So, go back to step one. Okay. Okay, so the first part of the piecewise function was parabolic, and the equation is 1/5 x minus 10 squared plus 6.09. So that would mean the vertex is at 10 kilometers with a 6.09 kilometers per hour pace. So that would be where they were running the slowest between those 3 points. And the, what is it called? The derivative is the y prime equals 2/5 x minus 4. So you can use that to find the specific pace of each, like where they start to slow down and where they start to increase speed anywhere along that line. And the domain would be 5 to 15 kilometers, and the range would be a 6.09 kilometer per hour pace and a 6.14 kilometer per hour pace. Next slide. And then the next part was the linear equation, which was what it was for the majority of the marathon. And that equation is negative 0.5x plus 6.875. So they're constantly slowing down at a pace of 0.5 kilometers per hour. And the derivative of that would be negative 0.5. And the domain is 15 to 40 kilometers, and the range is 4.91 kilometers per hour to 6.14 kilometers per hour. Next slide. Okay, and then the last part is the linear equation is 0.25x minus 5.09, so they're constantly speeding up by cutting off 0.25 kilometers per hour. And the domain would be 40 to 42.2, and then the range would be 4.91 to 5.46. So like that last stretch of 2.2 kilometers, they're speeding up. So we can finish nice. And I found the point of intersection between the first parabola and the linear line to find where it stops being that relationship and then becomes constant. And so that would be at 14.72 kilometers, and then they start running a 6.13 kilometer per hour. That's it. Okay, are there any questions?
As a non-math person, please tell me this is just sort of out of the blue.
Yeah.
What's the significance of them running, of it being a parabolic?
So,
as opposed to sine or something else?
well, it would mean that they start running, and then I think at 10 kilometers, right at 10 kilometers, they start slowing down at like the exact rate that they sped up. Or they slowed down up until 10 kilometers, and then they sped up again for the last 5 kilometers between 10 and 15 at the same rate that they slowed down, sort of. So they started out at a pace, slowed down to 10, at 10, and then sped back up. Yeah.
Do you know if it has anything to do with, stuff on the road that they're running on, and density of people running? Do you know if that's...
I don't know. They didn't, in the data, it was just a data chart of like that. They didn't talk about any conditions or anything. So
But it makes me wonder whether that would be replicated in other marathons.
Right.
It's more about the psyche of the marathon runner.
Yeah. You have questions, though?
Mine was just, so you're saying that there are points along the graph. Is it over time, their pace
So the x would be the distance, so 5, 10, 15 kilometers.
Okay.
And then the y is the pace, so
Okay, so
how
okay.
many kilometers they could run in an hour. Yeah.
Why did you choose this topic?
Well, originally I wanted to do the Boston Marathon, and just because I thought it would be something kind of different to look at, but then I couldn't find any data on it, so then I chose Chicago.
What does this say about their pace at the beginning, the very beginning of the race you're modeling?
Well, they start at about
Because there's no data point there at 0, right?
right.
But what does your modeling imply?
They start at 6.2. Like when they start running, they're on pace for a 6.2 kilometer per hour. And then they slow down and cover less distance in the same amount of time. And then speed back up.
Just get slower, slower,
Yeah.
That's right. That's pretty funny.
Yeah.
Cool.
And it's interesting because usually people talk about at like the 11th mile, which would be 22 kilometers. Like that's sort of like the halfway point. So it's interesting to look at like where people are, but it's not really reflected on this graph. Because I think usually at that people are starting to hit the hump, like being very tired. But it doesn't show up in here.